And with volumes in Kubernetes, we will be covering different kinds of them. So to start, we're gonna do something very simple. And again, I would recommend that you open up your terminal so you could follow along and run some of these commands. Okay. I don't think I'm sharing it. Let me share my screen. Screen's a little chaotic, so let me know if I need to clean it up a bit, if it's too messy to follow, anything like that. How did they move the share? There it is. Okay. Right. Let's clear up some of this noise. And to start, let's say create an empty directory anywhere. You don't need to make anything fancy. So no need to create a new repo or anything, just an empty directory where we can create some YAML configurations that we will apply using kube control. So I'm in my directory, and if I do an ls, I've got 3 YAML files here. Let's start with empty directory. And what empty directory is inside of Kubernetes, it's essentially like any other volume, except it doesn't persist. The goal is not for it to persist. It's really more of like a scratch pad of sorts, right? It's good to use for, let's say, in a development environment, for example, where you don't really, you're not concerned with persistent data, right? So when you write your config for uh, persistent, or sorry, for empty directories, it will look just like this. Very simple script. So in this example here, we're setting, like normal, our API version. We are defining a kind of pod. We're also giving it a name. We're going to call it web server. And we're going to be using an HTTPD container, or sorry, image. And we will name the container running that image web container -1. So try to get all of this down as fast as you can. It should be in the repository, though I think the repository, as of right now, the Bravo curriculum, it doesn't have all the changes that I've been adding. So that's just like broader introductory data information here and there. But these configurations should more or less be the same. I think some minor things change, like the configs up there right now might be using Nginx, for example. But you could still follow along, because really what we're concerned about is demoing these volumes, right? So here at the very bottom, we in our volumes block are specifying an empty directory, and we are setting a mount path to this volume mount at the cache directory. So what does that look like? Let's do a kube control get nodes to see if I still have anything running from earlier. Or sorry, I meant to say pods. Let's go ahead. I think that could stay up. That's fine. If we look at our ws1.yaml, this is the YAML that's inside of the repository that we're looking at right now, with a few additions, I think. So let me comment this out real quick. Save, and now I'm going to run my where I'm going to apply my configuration to spin up the pod. So I'm going to do a -f so I could pass in the file name. And the file name is ws1.yaml. It says the web server was created. So now I can do, somebody tell me, what can I do to see and confirm if this pod is up?
Get pods,
Okay, get pods. What else?
get deployments, get all.
Well, would any of that help us right now? Like, let's say right now, what we're trying to confirm is this volume and that it exists, right? So what kube control command can I run to do that?
Could be
And
just
get volumes.
yeah.
Sorry, a few people were speaking. What was that?
Go ahead, Eric.
No, you had it. Yam said get volumes.
Okay, let's see if that works. And it doesn't work.
Is it get volume singular?
It is not.
Hmm.
It still has to do with the pod, right? Because we are attaching the volume to the pod. So it's still the pod that we want to run this command with. It's just a different command. It's very similar to get, but a bit more verbose.
Describe.
Yes, perfect. Describe. So we're going to do a Q control describe. Let's see. What are we describing? What's this pod name? To get the pod name. Web server, right? So Q control describe web server. Whoops. Do not want to spell that out. Do not want a double L. And I don't have a resource named web server, probably because I didn't specify pod. So now that I specified pod and I don't have any more typos, we have the details on our pod, more verbose details, right? So we're able to see things like the container ID, the container name, et cetera, et cetera. And if we scroll down, we can see where the volume is created. We see it's an empty directory type, a temporary directory that shares a pod's lifetime. So remember what I said about this data not persisting, right? If this pod fails for any reason, if it gets killed or destroyed and Kubernetes has to spin up another pod, this data will be gone completely. So think of it as like temporary storage or stash for data. It could be handy, like let's say if you were, I don't know, in one of your applications or services, SSHing into this pod or execing into it, I should say, to, I don't know, look at log files. And maybe you need to do some data manipulation within those log files. And it's nothing too important. You're just trying to troubleshoot and find data. So you're maybe storing some of this stuff in an empty directory. Now, because you're troubleshooting an issue, let's assume that the pod is going to at some point get killed as you're trying different things. When you go back to the pod, as it spins back up, it's going to be a new pod. All this data will be gone. So that is the downside of an empty directory, but the upside is it's more or less fast, super available. You don't really have to do much to get it up and configured. So when it's there, it's there. It can also be shared by multiple containers in the same pod, right? So let's take a look at our configuration. We have this commented out, but I'm going to comment it back in. So now in our configuration, we have two containers specified, one HTTPD. I'm going to rename this web server to, or sorry, this container to web container 1, and the other container will remain as container2. I'm going to save. I'm going to shoot. Before I apply this, I wanted to actually also exec into this pod, right? So I think it's called web server. So I'm going to do kube control exec. What do I want to pass in as an argument? Am I recording? Yes, I am. Okay. Anyone?
If it's similar to Docker, IT.
Yes, exactly. And what does that stand for?
I'm gonna call a friend here if anyone can answer that.
All right, any friends picking up?
Interactive terminal, I think.
Yes. Awesome. So with an interactive terminal, I can see everything that, well, I could see all the commands that I'll be executing with exec, right? So I want to run this, but with the, I think the name, is the name web server still? And the last thing I want to do is specify an entry command. So in this case, if I just want to look around and create a file, I can just run very simple bash commands. So what I'm going to do is I'm going to call bin shell to start in a bash shell environment. So now that we are inside of our pod, remember in our configuration, we set a mount path to /cache. So if we go to that directory, we are now in cache. We can do stuff like make a new directory, cd into this directory, and let's use our handy dandy redirect to create a file. So Kubernetes redirect into, I don't know, hi.txt. And let's hit enter. Let's do an ls in our dir directory. Whoops, I guess. Oh, right, I cd'd into dir. So now that we've confirmed this file exists, I'm going to exit with Control D, and I'm going to go ahead and do a kube control destroy to destroy this pod. And again, I think I named it web server. Do I need to pass anything else to the destroy?
Destroy pods or
Yes.
destroy pod.
Oof. Thought it was. Let's see. Is it not destroy? If it's not destroy, what command is it?
I think it's delete.
Delete. Yeah, I keep mixing those two up. Thank you. All right. So we're gonna actually run delete, not destroy, and the web server is deleted. Now let's spin it back up. So we're going to run kube control apply. We're going to pass in that same configuration. I did save. So now there's going to be a second container, but that's okay. So kube control apply, the web server is created. Let's do a kube control get nodes. Oh, or not nodes, I keep terping. I mean pods. And we still have the web server pod up. Awesome. So let's go into that pod again. And I did change the name, I think, to web. Well, actually, let me show you this. So now that web server has two containers, if I just pass in this command without specifying a container, it should default me into one, right? So it's telling me defaulted container, web container one, out of these two available. So I'm now in my first web container. Let's go back into our cache directory, run an ls, and as we could see, this file no longer exists because when the pod was deleted, not destroyed, the empty directory volume ceased to exist, and the data that was stored on it also ceased to exist. So it's gone. But what is one of the other benefits of shared volumes? It's that it's accessible across all containers within a pod. So now if I do kube control exec IT-IT, and this time instead of passing in just the web server, I'm also going to specify the container that I want to exec into. So let's do web server, and I think I do another dash dash. No, actually not double dash, not yet. C for command, and or sorry, no, in this case, C for container. And I am going to pass in the name of the container, which is web container 2. And now I use my double dash, which, does anyone remember what the double dash does?
Just to give a command for the container.
Like, that's partially correct. Yes, I mean, it does give the command to the container, but can you elaborate and explain how that works?
I'm not sure, but it specifies the directory for which to go into.
Not exactly the directory,
Does
actually.
it determine the environment that you want to open the container in?
No, this double dash can be used in a lot of different ways. I covered it very briefly last Monday, I believe, when we were first, did I cover it? When we were first talking about how cube control and minikube work, right? So in, like, let's say a real live work environment, when you're running Kubernetes, kube control, it's going to be, I don't know, on like a host, a master node, right? And from there, you can exec into that, SSH into that, and run kube control commands. In this case, since we're just developing, let's say, we're using Minikube to spin up a Kubernetes cluster. So it's kind of like a VM. And Minikube itself has its own set of commands. So when we type things like Minikube, we can run commands that can't be run with kube control. And we set an alias so that when we run the kube control command, it's not actually running kube control by itself. It's running minikube kube control. I do remember the README says to set an alias, but I think Minikube also does that by default. So as soon as you install Minikube in an environment and it's ready to go, when you hit kube control and write any kind of command, it's actually an alias that you're calling, and the full command is minikube kube control. Now, what does that mean? When you're trying to, like, let's say, exec into a pod with kube control, if you don't use the double dash, the command's going to fail because it's trying to interpret the arguments that you're passing in as an argument for minikube, not kube control.
So it kind of specifies which aspect to give the command to.
Exactly, exactly. So in that same example, if we wanted to pass an argument to queue control, we use that double dash. I think it's like called a separator or something, just something simple like that, to specify that, okay, we're no longer passing arguments to the first command. We're going to be passing arguments to this new command. So here we are spinning up a container, and in this container, we want to be able to run a command. And so the command we want to run is just like earlier, bin bin.sh. And this allows us to open up a shell environment in our second container. Okay, so now that we're here in our second container, let's go back to that same, oh, yeah, let's try to go back into that same directory, right? So cd cache. Why doesn't it exist? It's because I intentionally set the mount path to a different directory. So if I go into alt cache and I do an ls, I see that it's empty again, right? Because we spun the node, we killed the pod, and so we lost the file. I should have made the file first, but let's go ahead and make a file again. So let's do, what was it? Echo Kubernetes. Let's just do something silly like that again with a redirect into hi.txt. Do an ls, we see that this exists. Now in this same directory, if I run an ls, we see the exact same file. I can even cat it just to make sure. And with the concatenate command, everything that we passed in is concatenated into an output string, and that's what we're reading. What is going on here? Does anyone want to take a stab at explaining how this works?
This is where you explained earlier that even though it's not persistent, while the container is still up, it can still share the volume between two containers, or as long as they're within the same pod, then they can share.
Exactly. And what about the different file directory paths?
Yeah, I'm gonna have to call a friend for that one again.
All right, does the friend want to take a stab? We could do another cube control describe, and let's describe all of our pods. If we expand this, so we could look at our pods. There it is. We could see web container -1 and web container -2. And this line here specifically in both configurations matches what we have in our configuration. We're setting a mount path for this volume. So both of these containers are using this volume. This volume lives, let's say, really more on the cluster, and it's available to this node, or sorry, this pod. And by mounting or setting a mount path, we are mounting this very same volume into a different location in each container. So it's kind of like, I don't know, what's a good example? It's kind of like a symlink or a shortcut, right? So that's what mounting is. When you mount, where else have you all used mounting? I think you guys have used mounting somewhere else. I'm trying to think. Is it in React? Is it in Django? Maybe Docker, maybe the Docker portion, you might have used mount here and there, but that's essentially what's happening, right? Regardless of the path that we're passing in, it's accessing the same volume. See, we see the name of the volume it's mounting is cache-volume, and that volume is specified down here as an empty directory. So that is the Kubernetes magic that's going on, that's allowing us to see the same files across these two different containers. All right, let's get out of here. Let's get out of here. I don't think I need these pods anymore, but we'll just leave them up for now. Let's switch over to talking about host paths and persistent volumes. And what these two have in common that the empty directory does not have is persistent data. Both the host path and the PV and PVC will persist over time. So if your pod dies for any reason and a new pod spins up, then that data will still be available. Now, there are a few, I guess, yeah, more than one difference. So a few differences between these two things, right? Here, let's just look at this configuration real quick. And if you are demoing along locally, go ahead and create a new YAML, name it whatever you want, and start typing this out. We are setting a V1 API. We're creating a pod. We're specifying a name, and we are specifying one container that is running Nginx. And we are also specifying a volume. Now, this time, we're setting for the type a directory, not an empty directory, but a directory. And we're setting the path to /data. So if I pull this up and let me scroll down, so that's all still visible. And cube control, get pods just to see what's running, because I don't remember. And I want to make sure I'm not spelling anything. Cool. So I don't actually have my host pod up. It needs to be spun up again. So let's go ahead and do a cube control apply -f so we could pass in a file name, and the file name, what did I name this? Let's do an ls. It's very likely hp1.yaml for host path. So hp1, tap to autocomplete, enter. And now we have our host path created. So let's go ahead and exec into this. I am going to do a cube control exec -it. I'm going to pass in the name of this pod, which is host path. I'm going to use my / separator, and I am going to pass in an entry command. In this case, again, I just want to be able to navigate the shell. So I'm going to do a bin /sh. All right. So I am now inside of this new pod, and we have set the mount path to data. So let's go ahead and cd into data. Let's go ahead and create a file. And it's going to say something like, let's see, I will persist. And we'll just call it, I don't know, hello.txt. do an ls to confirm it exists. Now let's get out of here. Let's exit out. Let's do a kube control delete. And want to make sure we pass in the right pod. So host path is the name. Host path has been deleted. Now, if I apply this file again, we're going to have a new pod. Let's, I should have done an inspect on that other path. So you could see that they'll have like slightly different IDs, right? Because that's kind of randomly generated. So let's just do a kube control describe on host path, which is a pod. And while it shares a lot of the same details as the previous pod, because it is using the same config, if I had run a describe on the other pod, we would be able to compare things like the container ID to see that they are different. So regardless of it being a new pod and it being a different container ID, if we were to exec back into this new pod and go into our directory where we've mounted our host path volume, we still see that the file has persisted. So just like an empty directory, the configuration is exactly the same, except for the type. We're just setting a different type. Now, what is persistent volume? If host path is a volume that persists, then why do we have persistent volumes? So Kubernetes exists in many, many, many layers. And while empty directories don't persist throughout multiple pods, and host paths do persist throughout multiple pods, host path does not persist through multiple nodes, whereas persistent volume would. So if I were to spin up my persistent volumes, which I think I've already done, so kube control get pods. Whoops. I am still in my shell, so let me exit out of here. We could see that my PVC pod still exists. What does this configuration look like? Let's take a look at that. So let's do code pv.yaml. I really can't type. And we see in our configuration a lot more than in the previous configuration. So let's just quickly step through this. What is happening here? First, we are setting a persistent volume. It's no longer a pod, but it's a persistent volume. We give it a name. We give it labels. We're able to set things like the storage capacity, its volume mode, the kind of access that users will have to it. And we're also, again, specifying a volume path. Look at the syntax. It can get a little confusing. Weren't we just talking about host paths? And this is now a PVC? Yes. So regardless of whether you are doing a host path or you're trying to create a PVC, be mindful of the syntax that you have to use. For the persistent volume, this is what you do to mount the path of the volume. Now, when we go down to our pod, that's where the syntax will look familiar. We see that there is a volume mount being specified and a mount path to data. And the name that we're using now is the same name of the volume that's configured up here. And this volume, it's not just a volume that was, let's say, where's that config? I already lost it. This is a totally different README. It's not a volume that, I don't know, exists on the, just exists on the node and is available only to, sorry, the cluster and is only available to these nodes, right? It can persist beyond that even. So it's through the use of a persistent volume claim and a persistent volume, it's able to persist data even if the entire node itself were to go down. And this more complex configuration is what allows Kubernetes to accomplish that kind of magic. So a persistent volume claim is essentially, I don't know, a key to a persistent volume. You need both in order for this kind of configuration to work. And then you need a separate configuration for a pod. And let's just step through the configuration for the claim. What we're doing is we're giving it a name, just like anything else. We're setting access modes. We're setting a file system, a lot of stuff that really matches what's above. And here, let's see. The name is my PBC. Oops. The key thing here is we are specifying the name of the claim in this volume configuration. And that is the configuration for persistent volumes. Any questions? Right, wrong thing. All right, today's assignment is to take a stab at writing some configurations to see what persistent volumes look like. So you'll be setting these up, maybe running a few describes. Try setting these up and then creating some junk data, and then try taking down the node, the entire node itself. If I run a Minikube status right now, you can see that I've got two nodes running. The control plane, which is sort of like the master node, as well as a new node that I have manually activated. When you run Minikube start, you can specify how many nodes to spin up. I didn't do that, but you don't have to stop Minikube in order to add another node. You could just do that with a command like Minikube add. So if I do Minikube add right now, we'll see that node add, I have to specify it's a node. We'll see that we could add another node, and it's now naming that node M03. Another way to inspect our nodes, of course, is to use kube control get and all the nodes. And we see that just like when we ran our Minikube status, we have some details on both of these nodes. Okay. That is the first part of the assignment. The second part is a continuation from Saturday. So I'm not quite sure we all left off with that, but give me a few minutes later on. I'll try to catch up in case any of y'all have questions on that. Okay, let's go ahead, stop this screen share.
I have a question on the add node or node add. What was it, adding a control node or a control plane?
No,
or
because
node?
you can only have one control plane. So what it's adding is just an entirely, let's say, I guess kind of like a worker node, if you want to call it that. Let's open up that terminal again. let's go ahead and let's do a more verbose analysis on this. Let's do a describe on all these nodes. Oh, who remembers the command for opening up the Kubernetes control dashboard?
Kubernetes dashboard. kubectl dashboard.
Because that is another way, if you haven't been using this, this is another way of being able to inspect your various commands. Is it Minikube? It might be Minikube. Yeah, it's Minikube. So running Minikube dashboard, we'll spin this up. And I don't know if I'm sharing my entire window or what here. So let me just find the Zoom thing so I could double check. Actually, can you see this? The dashboard?
No.
No.
Negative.
Congrats. All right, let me. I selected entire screen. I don't get it. Okay, is it sharing now?
Yes.
I see it.
Cool. So now if we go over to, what are we looking at? Our nodes. We can see, let's expand this. A reference to control plane here that the others do not have. And it's the same that you would see inside of the command line, but just, I don't know, maybe a little more aesthetically pleasing, if that's your preference. So does that answer your question, Eric?
Yeah, it does.
Okay, cool. All right, I've been talking for a while. I'm going to stop sharing. I'm going to cut the recording. I'm going to open up breakout rooms and y'all can take a break. Troy, actually, do you want to jump into a breakout room now or do you want to take a break first?
We can jump into a room now and knock it out.
Cool. All right, let's do that. Everyone else, I will open up breakout rooms.